Let's pay attention to this one. It has two bases with two exponents, and we know we have to log both sides. That doesn't change, okay? There's no change in that. We log both sides. So we're going to go log. Now, in order to stop you from trying to make them be base 2 and base 6, remember I told you to log 10 both sides at first, just so you don't write it in wrong. So I always go log base 10 and then go 2, and then I put a multiplication symbol, 3 to the x, because the x is only to the 3, equals log base 10 of 6 to the x plus 1. Now, once you move the exponents down in front, you can get rid of the log base 10. But the log base 10 is just there. If you're someone who's going to keep trying to drop that number into the base, then write log base 10 the whole way along. Because I find that when people don't put log base 10, they'll put log, and they'll put a 6 here, and then they'll put the x plus 1 beside the log. They do it all the time. So at least if you put a 10 in there, you can't, because you already have it full with something. Yo.
Is that log 10 being applied to 2m, 3x?
Yeah.
So can you put like a bracket around there?
Technically. You could go like that. What's the catch here? The next step we did before was we took the exponent, we dropped it in front, correct?
Yes.
You could do that if the x was to both the 2 and the 3, is it?
No.
No. So there's one extra step in here. One extra step. And this happens when you have this number can't divide over. You know, like in the other example, we had it as the I value, and we could divide it over because the f value didn't have any variables on it. So it was easy. We could divide them over together. We can't. If I take the 2 and divide it over here, it's just going to be 6x plus 1 over 2. It won't be 3, which is what everyone does. Do not do that. If you divide the 2 over, it can't join this one. The x plus 1 is only on the 6. Okay? So what rule do we have when we have multiplication? What can we do?
Oh,
Add.
oh,
Add. Yeah, by adding. So we're going to get log base 10 of 2. This is just the one little extra step. Plus log base 10 of 3x, 3 to the x, sorry, equals log base 10 of 6 to the x plus 1. So this here is the one extra step. That's it. And then the rest we do exactly how we did before. There's literally one extra step. That's it. What did we do before? Take the exponents. Take the exponents and do what with them? Put them in front. What do you have to remember if the exponent is a binomial or a trinomial? You have to remember to distribute it. So we're going to get log base 10 of 2 plus x log base 10 of 3 equals x plus 1. Whenever my exponent is a binomial or more, so not a monomial, I put it in brackets, so in hopes that it reminds me I need to distribute it. Log base 10 of 6. If you're someone who will never write those numbers as the base, then you can drop the 10s off. You don't have to write the 10s. I'm doing the 10s because I know how many times people mess this up. Like lots, if they don't put the 10s. They drop that number down. So our next step is to distribute. Log base 10 of 2 plus x log base 10 of 3 equals x log base 10 of 6 plus 1 log base 10 of 6. What was our next step?
You can divide something or do something like that. Oh, take out an x.
Can't take out an x until any term with an x has to be on one side, and anything without a term without an x, sorry, has to be on the other side, so that we can take that x out. You're right. So you can pick and choose which side you want. It doesn't matter. I can move this x over here or this x over here. Remember, that's why the answer sometimes is the exact same as yours but opposite sign, because they chose to move the other one over. That's it. Not a big deal. Just make sure that your answer is exactly the same as their answer, but all opposite signs, every single one. If only two of your signs are opposite and one's the same, something's wrong. Okay? So I'm going to move this one over because for some reason I like having x's on the left. It's just a preference. So I'm going to get x log base 10 of 3 minus x log base 10 of 6 equals log base 10 of 6 minus log base 10 of 2. Then Connor, what'd you say? Oh, crud. I can't see your name on here. Flonner? No. Yeah. X. Flonner. Good answer. X log base 3. At this point, I'm going to drop the 10s off. If you want to keep the 10s till the end, go right ahead. I'm just going to drop them off. So log base 3 minus log base 6 equals log base 6 minus log base 2. Then what do we do? Divide to get that x by itself. Now, some people get right to here, and they're like super awesome, and then they do something really stupid. Log 6, cross them off, makes nice life easy. No. There's negatives in between these. There's subtraction signs, and subtraction signs sew those logs together. Subtraction signs and addition signs sew. They sew whatever's on both sides of them together. They're one unit. The only way that one unit can go away is if that exact one unit is on the bottom. So if this entire log 6 minus log 2 is on the bottom, you could cross it off. But is it? No. So we're stuck here. Now this would be okay to get an approximate. So you're going to give me an approximate, and then we're going to go and show you how we put it together as one single log. Because remember, we can do that. So how do we get an approximate? Punch into our calculator. Make sure you put the top in brackets and the bottom in brackets. So we're going to get x is approximately, this little squiggly equal sign means approximately. And you're all going to punch into your calculator. If you had kept the base 10s, you could have used base 10 and divide them out. Or you can know, hey, when a log doesn't have a base, it's base 10. That's why the 10 can go away. What mode do we have to be in? Degree, radians? Trick question? It doesn't matter, because it only matters if we're pressing sine, cos, or tan, or second sine, second cos, second tan. At any point, are we pressing those buttons? No. You could have your calculator in the radian mode, and it wouldn't matter. There's no such thing. I'm just saying. It doesn't matter. Okay? Degree and radian only matters when you're pressing those buttons. If you're not pressing those 3 buttons or the second of those 3 buttons, your mode does not matter. So what'd you get it to be? Negative 1.58. So that's approximately what it would be. So if it was a numeric response, how could they ask this as a numeric response? They could ask you for the absolute value of x, could they not? To the nearest hundredth. If they asked for the absolute value of x, they would get rid of that negative sign and you write down 1.58. Okay? Or they could say the absolute value of x to the nearest tenth, then it would be 1.6, right? Just so you know, I'm starting to crack down on improper rounding. For your next test and for your next cum, every time you improperly round on a numeric response, you're losing 0.5. For the test after that and your mock, anytime you round wrong, you get 0. Because what would happen on your diploma? You get 0.
You don't have Miss Lepp to help you out.
No heart. Okay, so now we're going to go here, and we're going to go x equals. How can I put these top ones together?
Subtraction.
Subtraction means we can put them together by dividing. So on the top, I can combine them, and I get log, and I can combine them because they're both base 10, right? So I get 6 over 2. What if they had numbers in front of them? You'd put it up as the exponent, and then you can put them together. Exactly. Now, on the bottom, I'm going to have log 3 over 6. Now, that reduces to log 3 over log 1/2. Which is still a good answer, but they're going to go one step further. Do you remember what we can do there? Remember there's that rule I told you, you guys are really good with it going this direction, but when we go backwards, you don't spot it? No. If I give you this, if I gave you log base 7 of 9, what would you tell me to do? How could I punch in my calculator if it didn't have the base button? You'd go like this, bam, right? Right now I have that. How could I put it together? Log 1/2 and then 3. No one remembers this rule. Everyone remembers it this way. It's on your formula sheet. It's the last log law. Okay? You have to remember that. You have to remember that you can go from a log over a log to a single log.
It's the same.
Yes. So you're going to go to your textbook and you're going to do 7D, and then we're moving on. From yesterday, 7D. So type 1, we have solve log base 9x plus log base 9 3 equals 1. When they're basic like this, the best thing you can do is there's a huge hint here. If you look, they both are base 9. If any logs are the same base and you're adding or subtracting them, there's a huge chance you're going to be putting them together by multiplication or division, right? So these ones here, you're going to go log base 9. This one's a plus 1 in front, so it stays on the top. This one's a plus 1 in front, so it stays on the top. What do we do with those two things? What do we do with these? Multiply equals 1. So now we have log base 9 3x equals 1. And what did I tell you in the last lesson? If you don't know the x value beside the log, or you don't know the x value of the base, say the variables in the base beside the log, or the variables beside the log. So in any way, if the variable is beside the log, what do we have to do? Change it to exponential. Okay, so we change it to a log from exponential when we can't make common base, right? We change logs to exponential when we don't know this value, the base, or we don't know the thing beside the log. How do we change it to exponential? When you have a basic log like this, you just do 9 to the power of 1 equals 3x. I always do 7 rule. 9 to the power of 1 equals 3x, but the log has to be on the left. 9 to the 1 equals 3x. If you don't remember that, the base of the log becomes the base of your exponent. What it equals is always your exponent, right? And then what's beside it gets beside it. So whatever's friends in logs is not friends in exponential. Just remember that. If these two are beside each other here, they're not going to be beside each other in exponential. So now I have 9 equals 3x, because 9 to the 1 is just 3, or 9. Divide by 3, and I get x equals 3. What's the catch with logs? You always have to check your answer. Remember yesterday when I was talking to you, and I said to you, hey guys, could we put a 0 beside the log? Would it work? And you guys said no. Then I said, well, put a -1 beside the log. Would it work? And you guys said no. Remember that? So when we plug this back in for x, you can't have a negative base. You can't have a base of 0. You can't have a negative number beside it, and you can't have the number beside it be 0, right? So we plug it back in, and we get log 9 to the 3. So we're good. Okay? So this is good. You can also always do what? It's an equation with one variable. The variable is x. What could I do to check this? y1, y2 is not changed all the way through the years, the entire year. If I have something equals something with one variable, so like just x, I could have x in a few spots, it doesn't matter. But as long as the only variable throughout the whole equation is x, or the whole variable throughout the whole equation is m, as long as it's the same letter throughout the whole entire equation, I can y1, y2 and check these. Okay? So when you check it, try it. Punch in the original. And always, please, always punch in the original. Don't punch in something that you've messed with, because you have a chance of making an oopsie. Okay? So always plug in the typed version. Really need to get my online calculator back. And then what do? Second trace 5, enter, enter, enter. Okay. Example 2, same deal. We're going to put these together. They both are base 5. Always, you guys, the best thing to do is keep the logs on one side and the numbers that don't have logs to the other side, right? Because you're going to try and convert it to a log after, or to an exponential after, and that's how the form it's going to have to be in. So if this 1 was over here as a -1, I would move it onto this side and make it a +1. Because I want to have the logs on one side and everything else on the other. So I'm going to go log base 5. Come on. There we go. X plus 1 times x minus 3 equals 1. Now I have log base 5 of x squared, FOIL it out, minus 3x plus 1x is minus 2x. 1 times -3 is -3 equals 1. Now I don't know what's beside the log. If I don't know what's beside the log, or the variable is what's missing, which is beside the log, what do? Convert it to exponential, because I have one log, right? So I'm going to get 5 to the 1 equals that. Now we're back to grade 11. I have a quadratic. When I'm solving a quadratic, I move everything to one side, set it equal to 0, and then factor. And if I can't factor, I use quadratic formula. So subtract 5. And I get 0 equals x squared minus 2x minus 8. And I say to myself, what times what is -8? And what plus what is -2?
4 and 2.
-4 and 2. Do I have to do decomp, guys, or can I just do product sum? Why? Because there's a positive 1 in front. What if there was a -1 in front of the x squared? You could either do decomp, or, hey, it's equal to 0. I can just move all 3 terms to this side, and then it's positive and do product sum. Yeah. Every time I do that, everyone's like, oh, but I've done it to you guys 4 times this semester. And every single time you're like, it's like brand new. It's like the first day you heard it. Ooh. I like it. So 0 equals x minus 4, x plus 2. And then we solve them out. So x equals 4 and x equals -2. What do I have to remember to do?
Check them.
Okay. So I go back to my original and I fill it in beside my log. So I fill the 4 in. 4 plus 1 is 5, so that's bigger than 0. Yay. 4 minus 3 is 1, so that's bigger than 0. Yay. -2. -2 plus 1 is -1. Can I do log of -1 divided by log of 5? No, this one's out. This is called extraneous. Now, I'm going to tell you how they give this question on the diploma. If I were the person writing the diploma, this is what I would do. You can Y1, Y2 this, absolutely, correct? And it's going to give you the correct answer. It's going to give you 4. Anywhere on there going to show you the -2 answer? No. Nowhere on your calculator is going to show you the -2 answer, because the -2 answer doesn't exist. The -2 answer only shows up when you do it algebraically, correct? So if I were writing this question and I wanted to see if you actually could do it algebraically, I'd ask for the extraneous root. Because you can only find the extraneous root, the root that doesn't work, the root that doesn't exist, if you actually solve it algebraically. Once again, they're bringing back written, and with written, then they don't have to do funky ways of asking it like that on the diploma, because the written would be just solve this, and you'd have to show me how to do it, right? Solve algebraically. And then if you Y1, Y2'd, sorry, not going to work. Okay. So this one doesn't have a number. So there's 2 ways you can do this. You can either move it all to one side equal to 0 and then change it to a log, or change it to an exponential, or you can keep the logs on both sides. I'll show you keeping the logs on both sides just in case you see it. This only works if you don't have like a number, like we had equal to 1 before or equal to 3, right? So we had to do that. If you just have logs, you could combine this side and you can go log x over 15 because they both have positive and negative ones in front. If they didn't, they'd expect you to bring them up as the exponent, which is probably more so what they'd give you. And it equals log of 0.2. So if this is log base 10 and this is log base 10, what must this and this be then? If these are the exact same logs, and I have log something equals log something, what can I say about the somethings? They're the same. So after this step, what can I do? Just take those somethings and set them equal to each other. Because this has to be equal to this. This x over 15 has to be equal to 0.2. If you're like, no thanks, I don't like that one, you could move it all over to this side equal to 0 and then change it to an exponential. I like showing this method because what if they do the whole, where do you make a mistake? And you're like, he didn't make it equal to 0, obviously, but that's not an option. We have to show you the different ways too. Okay? So what am I going to do? I'm going to multiply by 15. This is actually way faster if you spot this. And what is it? 3. Then we have to check it. Put a 3 beside here. Yay. We're good. It works.
That was really easy compared to the last one.
If you spot that there's only logs, this is way easier. If you don't spot it, at the very least, move all the logs to one side and change it to exponential. Okay? So this one, we can combine these. Now, there's a catch too. What they could do is put coefficients in front of these logs. Then you couldn't just combine them right away, right? If they put coefficients in front of the logs, what would you have to do first? Move them up as the exponent, and then you could combine them, right? Because we can't combine unless we have positive or negative ones in front of our logs. So we're going to get log base 3, and then we have x times x minus 1, because they both have plus 1s in front, equals log base 3 of 6. This only works because they're the same log base as well. You couldn't do this if one was like log base 3, one was log base 7. You can say, oh, the somethings have to be the same. No, they don't. The bases were different. So they always give you the same base, obviously. Okay. So we get log base 3 of x squared minus x equals log base 3 of 6. Correct? If this is true, this something in brackets has to be the same as that something in brackets, correct? If that statement is true, they have to be equal. So now my next step is to just make them equal. And then when everyone thought grade 11 was hard, this was one of the hardest things you were given in grade 11. A quadratic you had to solve, and now you're like, dang, I should have really loved grade 11 more. I should have really taken it in and been super happy about it. So what do I do when I have x squared minus x equals 6? Move it to
The other side.
and set it equal to,
0.
and then what?
I don't know.
Factor or quad formula if you can't factor. So we're going to get x squared minus x minus 6 equals 0. Quadratic formula is completely fair for them to ask. It's actually the very top of your formula sheet. So if they give you one that doesn't factor, it's completely fair. You don't even have to memorize the quadratic formula. It's on your formula sheet. So now we get x minus 3, x plus 2. We don't have to do decom because there's a 1 in front of the x squared. We get x equals 3 and negative 2. Now, some people start getting to the point where they think 1 always has to go away. That's not the case. You sometimes can have 2 answers. You sometimes can have 1 answer. Sometimes both answers don't work. There's no guarantee as to it's always 1. Okay? So I take the 3 and I plug it back in. A 3 beside here, safe. 3 minus 1, a 2 beside here. So that's safe. I take the negative 2. I have a negative 2 here. Not good. Extraneous. Because you can't go, try in your calculator, go log base 3 of negative 2.
Just gonna say error. I guess it's error. Unreal answer.
So that's why.
All right. So it's never a negative.
Well, it could be a negative technically if it was like something minus x.
Yes.
If it was 2 minus x, it'd be minus minus. So you can't just cut out the negatives either. Like some people are like, a negative's gone. No, you have to check them back.
But it's just like an x, like in the first term.
Then yes. Yeah. And you can always check in your calculator, right? Y1, Y2 to guarantee. Like you should walk away. If this is a written response, you should walk away knowing you're completely correct or you oopsed. Because you can just Y1, Y2 and see. If you're solving an exponential one, you should be able to walk away from the test knowing if you oopsed. Y1, Y2, you can check them, right? That's why I put them in the written response, so I can see you doing the work. Okay, try this one. It's not hard. It's not hard. Just remember to do what?
Yeah, delete the logs.
No, remember to do what first? Bring that 2 up. That's it. So we get log x squared, bring the 2 up, equals log 3 times 27. So it's going to be log x squared equals log 81. And you're going to get x squared equals 81, square root it, and what do you get? Plus or minus 9.
Right, plus or minus.
Which you're extremely lucky if you forget that, and I'm just asking you for the answer because the negative 9 is extraneous. However, if I ask you for an extraneous root, you'd be like, there isn't any. It's a horrible question because you forgot to positive and negative it. So the answer is x equals 9 and x equals negative 9 extraneous. So it actually doesn't equal. And this is the actual correct answer. Yo. It's when you put it in before that. I hear you though. I see ya. I get ya. But it doesn't work that way. That's why it's always good to check them into your Y1, Y2s as well. But I totally get you. All right. I'm going to get you to do this last one here. And then I'll tell you which ones to do in your text